Let's see the Schrodinger wave equation. So Schrodinger wave equation is d square psi upon dx square plus d square psi upon dy square, d square psi upon dz square plus 8 pi square m upon h square e minus v psi equals to 0. ठीक है, यहाँ पर psi क्या represent कर रहा है? Wave function or the amplitude of the electron wave. X, y and z are the space coordinates which describe the three-dimensional motion of electron. Okay, because we are considering the wave nature of electron. So this Schrodinger wave equation, which was given by Erwin Schrodinger, is basically the heart of quantum mechanics. Right? So m here stands for the mass of electron. H is the Planck's constant. E represents the total energy of an electron. V represents the potential energy of an electron. Basically, E minus V represents the total minus potential. So that represents the kinetic energy of an electron. Right? So from the knowledge of psi, we can solve this equation. And when you solve this equation, we come to know the value of total energy, potential energy, and three constants can be calculated like N, L, M, the quantum numbers that we call them. ठीक है, अच्छा यहाँ पर ये जो फर्स्ट थ्री टर्म्स हैं on the left hand side, इनको collectively जब हम लिखते हैं, we write them as del square psi. Right? They're represented as del square psi. So in place of these three terms, we can write del square psi plus 8 pi square m upon h square e minus v psi equals to 0. Okay? This is another way to represent the Schrodinger wave equation. So ये पूरा जो this equation is a partial second order differential equation. So this part we are representing as del square psi. Now let's look at the important features of the model. क्वांटम मैकेनिकल और द वेव मैकेनिकल मॉडल के जो इंपॉर्टेंट फीचर्स हैं वो क्या है? वेव मैकेनिकल मॉडल इज आल्सो कॉल्ड एज क्वांटम मैकेनिकल मॉडल. So what are the important features? Just like the Bohr's concept, the energy of electrons according to this model is also quantized. What do we mean by quantized? That is, they can have fixed values of energy. They can have specific values of energy. Right? Second is, this model provides most probable regions in the atom where there is maximum probability of finding the electrons. Now, such regions with the probability of finding electrons is maximum, they are termed as atomic orbitals. ठीक है, regions where the probability of finding electrons is maximum, they are termed as atomic orbitals. So this concept provides information about the atomic orbitals. Then, because this model does not specify the exact position and momentum of electron, it is in accordance with Heisenberg's uncertainty principle. ठीक है, हाइसेनबर्ग ने क्या किया था? बोहर का जो कॉन्सेप्ट था सर्कुलर ऑर्बिट्स का, वो कंट्राडिक्ट किया था, बिकॉज ही सेड सर्कुलर ऑर्बिट्स हम तब बोल सकते हैं व्हेन इलेक्ट्रॉन जब इलेक्ट्रॉन का पोजीशन और उसका मोमेंटम हमें पता है, देन वी कैन डिफाइन द इलेक्ट्रॉन इज प्रेजेंट हियर एंड मूविंग विद दिस पर्टिकुलर velocity, then we can define the circular orbit. But till the time we don't know the exact position and momentum of electron, we cannot define its path. So this model does not define the exact position and momentum of electron. ठीक है, मतलब ये हाइसेनबर्ग uncertainty principle को follow करता है. It is based on Heisenberg's uncertainty principle and it also follows the de Broglie's concept of dual nature of matter because it considers the wave nature of electron. Right? Let's go through it. Okay, now let's see the other points. An atomic orbital is defined as the region of space where the probability of finding electron is maximum, right? An atomic orbital is defined by a wave function psi. Since many such wave functions are possible for an electron, there are many atomic orbitals in an atom. Right? So this is your electron wave. This is psi. So many such amplitudes or wave functions are possible. So corresponding to different psi values, there will be different atomic orbitals. Now the square of psi is called as electron density or probability density. And the probability of finding the electron at a particular point within an atom is proportional to psi square. Okay, psi square at that point. Psi square is known as electron density or probability density. Psi square is also called as electron density or probability density. So this square of psi, just like the square of amplitude gives you the intensity of a particular wave, in the same way, square of psi gives us the intensity of the electron wave. That is the electron density at a particular region or at a particular point. It is also called as probability density. See, psi may be positive or negative, right? But psi square of psi will always be positive. Negative into negative will give us a positive. Okay? So psi may have positive and negative values, but psi square will always be positive. Then solving, when you solve this Schrodinger equation, from there we get three constants n, l and m. The solution of Schrodinger wave equation gave us three constants n, l and m. So n is your principal quantum number, l is called as azimuthal, and m is called as magnetic quantum number. So these three quantum numbers have been calculated from the solution of Schrodinger wave equation. And they tell us about the position, energy and orientation of the electrons within an atom. ठीक है? कि इलेक्ट्रॉन का क्या मेन शेल है, क्या सब शेल है, कितना नंबर ऑफ कौन सा ऑर्बिटल में वो प्रेजेंट है ना? So it tells us about the energy, the exact location of an electron within an atom. Then the shapes of the various orbitals. So the information about the exact shapes of various orbitals have also been provided by this model. Okay? So s orbital is spherical. So when you solve this Schrodinger wave equation, so corresponding to that, we get different shapes. Actually, graphs like p के लिए जब हम solve करते हैं तो इस तरह का ग्राफ आता है. ठीक है? So that is why the p orbital is called as dumbbell shape. S orbital, we get a graph like this. So all the shapes have been calculated mathematically. So s orbital is spherical, p is dumbbell shape, then d orbital is bidumbbell. Bidumbbell means there are two lobes. So s is spherical, p is dumbbell shape, d orbital is bidumbbell. So these shapes have also been predicted on the basis of the solutions of Schrodinger equation. Okay? The graphs that have been calculated based on the Schrodinger equation, from there we kind of derive these shapes. So S is spherical, P dumbbell, D is double. So these are some of the important features of the Schrodinger wave equation. Important features of the wave mechanical model, which is based on Schrodinger wave equation, right? Okay, now let's see the wave function psi. Psi can be defined with respect to the space coordinates x, y, z, and it can also be defined with respect to the polar coordinates, that is r, theta and phi. R here stands for the radius and theta and phi for the angles, right? Suppose there is a particle at this particular point. So the position of a particle can be defined with respect to the space coordinates x, y, z, or with respect to the polar coordinates, that is the radius r and angles theta and phi, right? So we have divided the wave function into two parts, that is radial part of the wave function and angular part of the wave function. Radius part of the wave function depends upon r, and angular part depends upon the angles theta and phi. Okay, and it also depends upon the values of quantum numbers n and l. Okay, main shell and the subshell, and the angular part depends upon the l and m values. Right? So we have divided the wave function into two parts: radial part, which depends upon r, and the angular part, which depends upon the angles theta and phi. Now when we square the psi, wave function का जब square करते हैं तो क्या पता चलता है? Probability density. The same way, अगर हम radial part of the wave function का square करेंगे तो radial probability density पता चलेगा, और अगर हम angular part का square करेंगे, ठीक है, so angular probability density will be known from there. So square of r gives you the radial probability density, and square of a, that is the angular part of the wave function, gives us the angular probability density. Just like when we square psi, we come to know the probability density. बस उसके दो parts कर दिए, एक radial और एक angular probability density. Okay. So now let's see what is a node. Node is a place around the nucleus where the probability of finding electron is 0. Okay? What is a node? It is a place where the probability of finding electron is 0, excluding the nucleus obviously. So around the nucleus, the region of space where the probability of finding electron is 0 is called as a node. Now node has been divided into two types: radial node and angular node. Radial node is also called as spherical node, and angular is also called as planar. तो इसके लिए आप याद रख सकते हो पारस. ठीक है, PA stands for planar and angular, they mean the same. Radial and spherical means the same. So if they ask you radial node or spherical, it means the same. If they ask you planar or angular, it means the same. Now the formula to calculate radial node is n minus L minus 1. The number of radial nodes is n minus L minus 1. N stands for the main shell and L for the subshell. ठीक है, and angular node is equal to the L value. जो भी L value है उसके equal angular node होगा. And total nodes is sum of radial and angular. इन दोनों को sum up करेंगे तो total nodes आ जाएगा, which is equal to n minus 1. So total node means radial node plus angular node. अब यहाँ पर for example देख लेते हैं 1s, 2s and 2p. अब 1s के लिए n का वैल्यू क्या है? 1. And for s orbital the value of L is 0. ठीक है, so n minus L minus 1. So 1 minus 1 will give us 0. So radial nodes will be n minus L minus 1. N minus L minus 1, that is 0. And angular node is equal to L value, that is again 0. So 1s orbital में क्या है? Suppose हमने 1s बनाया तो यहाँ पर कोई भी angular node नहीं है, ना ही कोई spherical node है. ठीक है, in 1s orbital there is no there is no such region where the probability of finding electron is 0, neither along the radius, neither along any angle. ठीक है, so 1s orbital में कोई भी node नहीं है, ना radial ना angular. So total node is n minus 1. 1 minus 1 मतलब 0. The total nodes are 0. Now let's see for 2s orbital. The value of n is 2 और s के लिए जो corresponding L value होता है वो 0 होता है. Now n minus L minus 1. So 2 minus 1 gives us 1. So there are 1 radial node, but the value of L is 0. So angular nodes कितने हो जाएंगे? 0. ठीक है, और total nodes कितने हो जाएंगे? 2 minus 1, because n का value 2 है. 2 minus 1, the total nodes is 1, or you can sum them up. ठीक है, तो वहां से total nodes find कर सकते हैं. अब ये 1 कौन सा नोड है? रेडियल या स्फेरिकल. ठीक है, तो जैसे ये 1s ऑर्बिटल है, सो 1s और 2s के बीच में एक रीजन या स्पेस होगा where there will be no electron density. राइट, सो 1s और 2s के बीच में इस तरह से Suppose here we have electron density. So this is 1s and this is 2s. So in between there is this spherical node, a region of sphere between 1s and 2s where there is no electron density. So this is 1s orbital and this represents 2s orbital. So in between the two there is this spherical region where there is no electron density. We call it as a node. ठीक है, तो ये कहाँ पर है? 1s और 2s के बीच में. So we have a spherical or radial node in 2s, but there is no angular node, है ना? So along the angle अगर हम visualize करें तो ऐसा कोई node नहीं आ रहा है along the angle because it is spherical, है ना? तो ऐसा कोई angle नहीं बनेगा जिसके along electron density 0 होगा. Then next is 2p. Now the value of n is 2 and for p orbital the corresponding L value is 1. ठीक है, so n minus L that gives me 1 minus 1 that gives me 0. So there are 0 radial nodes and there will be 1 angular node, right? So total node is 1. तो 2p orbital कैसा होता है? Suppose like this. This is your 2p orbital. So in 2p orbital, spherically अगर हम देखें तो along the sphere there will be no node present. There is no node along the radii, but there is one angular node, right? So if you move along the plane of the molecule, so if you move in the molecular plane, so along the plane of the molecule, there will be angular node. Okay, so along the plane of the molecule when we go, there will be angular node. So there is only one angular node and no spherical node in 2p orbital. Just go through. And how to find the total number of nodes? Simply n minus 1 or sum of spherical and the planar nodes. Angular plus radial nodes को sum up करेंगे, that gives us the total number of nodes. Okay, now let's see what is radial probability distribution function. See, R represents the radial part of the wave function. Wave function हमने क्या लिया था? Psi. तो उसको दो parts में divide किया, radial and angular. So R represents the radial part of the wave function. R square represents the radial probability density. Now there is another term that is radial probability distribution function. It represents the total probability in volume between R and R plus dr. Basically, radial probability distribution function कैसे आएगा? Probability density को जब हम volume of shell से multiply करते हैं, ठीक है? So suppose this is your radius R and this represents the shell. This shell is R plus dr. ठीक है, तो हमने इसका वॉल्यूम फाइंड करना है, इस पर्टिकुलर शेल का वॉल्यूम. सो वॉल्यूम ऑफ शेल विल बी इक्वल टू वॉल्यूम ऑफ द इनर पार्ट दैट इज 4/3 pi r cube and volume of the outer sphere, inner sphere and outer sphere. तो outer sphere का वॉल्यूम है 4/3 pi r plus dr का क्यूब, right? This distance is r, so this is r plus dr. So volume of the outer sphere minus the volume of the inner sphere, that gives you the volume of the shell. ठीक है, volume of the spherical shell. So because spherical shell है तो volume of sphere यूज कर रहे हैं, तो उसको सॉल्व करके हमारे पास ये वैल्यू आती है. ये क्या है? This is the volume of the spherical shell. Now volume of the spherical shell multiplied with the probability density. So radial probability density r square है, volume of the spherical shell is 4 pi r square into dr. This gives us the radial probability distribution function, meaning it gives us the total probability in terms of volume of the shell. ठीक है, so it represents the total probability in terms of volume. So it gives us the total probability of volume, total probability of volume between r plus dr and r, or you can say the total probability in volume of a particular shell. Okay, so we have three things. One is radial part of the wave function, square of that is the radial probability density, and that radial probability density when multiplied with the volume of the shell gives us total probability in terms of volume. So that is called as radial probability distribution function. And it is equal to 4 pi r square into dr. So dr के बाद neglect भी कर लेते हैं, तो normally 4 pi r square into capital R square. Now just like in maths you have sine theta, cos theta curves, here also we have different curves based on the radial probability distribution function and with respect to R square. But you don't have to learn the equations here, just the curves are important. ठीक है? So ऐसे different equations से related curves होते हैं, तो यहाँ पर हमें equations याद नहीं करनी है, simply curves का थोड़ा सा ध्यान रखना है. Now let's see the curves. So this is for 1s, 2s, 3s and 4s orbital. So the first curve is r versus r. The capital R stands for the radial part of the wave function and small r for the distance from the nucleus. So as we move away from the nucleus, the the radial part of the wave function, it decreases. Okay? And square of the radial part of the wave function gives you the radial probability density. Electron density or radial probability density. So we can say the electron density decreases as we move away from the nucleus for 1s orbital. Okay? So as we move away from the nucleus, the electron density decreases for 1s orbital. Now 2s orbital के लिए, this is the wave function, radial part of the wave function, right? And जब इसका square करेंगे तो क्या हो जाएगा, जो negative part of the wave function है, when we square it becomes positive. So for 2s orbital, first the electron density decreases, becomes minimum. This point represents 0 electron density. Then again the electron density increases and then again decreases for 2s orbital. Right? So again, this is the radial wave function for 3s. And when you square it up, so the negative part of the wave function will become positive on squaring. ठीक है? तो यहाँ पर इस तरह से 3 पीक्स होंगे. ठीक है? जितना पीक्स यहाँ पर है, बस ये जो नेगेटिव पार्ट ऑफ वेव फंक्शन इसको स्क्वायर करेंगे तो ये पॉजिटिव हो जाएगा. सो व्हेन वी टेक द रेडियल प्रोबेबिलिटी डेंसिटी स्क्वायर versus r for 3s orbital, so the electron density first decreases, becomes 0, then again increases, again decreases, becomes 0, then again increases, right? So we have this way, we have 3 peaks for 3s orbital. Then again for 4s, this is the radial part of the wave function. जो भी negative part है इसमें wave function में, जब square करेंगे तो ये positive हो जाएंगे. ठीक है? So 4s orbital के लिए क्या है, इसमें भी same है. पहले electron density decrease करेगा, becomes 0, again increases, then again decreases, increases, decreases. So again we have 4 peaks, like 3 peaks and 1 this decreasing order. Okay? So for 4s orbital from the nucleus, as we move away from the nucleus, the radial probability density increases, then decreases to 0, then again increases. So accordingly we have 3 peaks. 4s के लिए इस तरह से 3 peaks है और ये decreasing curve रहेगा from the nucleus. Just quickly draw the graphs. Then we will see the radial probability distribution function that gives us the total probability. That gives us the total probability in volume. So how does the total probability vary with r, distance from the nucleus? Okay, now let's see the radial probability distribution function versus r curves. So 4 pi r square into r square versus r. Now see the density has been multiplied with r. ठीक है? So radius के साथ जब multiply करेंगे तो क्या होगा? When r is 0, so even the radial probability distribution function will be 0 because r square multiplied with 0 will give you 0. So when radius like close to the nucleus, when r is 0, r square multiplied with r will also be 0. So रेडियल प्रोबेबिलिटी डिस्ट्रीब्यूशन जो फंक्शंस है वो कहाँ से स्टार्ट होते हैं? ओरिजिन से. ठीक है. So 1s के लिए the curve is like this. There are no nodes. For 2s there is one region where the total probability is 0. So that represents one node. So for 2s there is one radial node. For 3s there are two regions with the total probability 0. So there are two nodes for 3s orbital. ठीक है, because we are taking the radial probability distribution function, radial part, so we are talking about the radial nodes here. Then for 4s orbital there will be 4 peaks, right, and the number of nodes will be 3. So there are total 3 nodes for 4s orbital. और जैसे जैसे r बढ़ता जाएगा, रेडियस बढ़ता जाएगा, टोटल प्रोबेबिलिटी विल इंक्रीज. ठीक है. सो द कर्व्स जो है दे बिकम बिगर एंड बिगर. सो 4s के लिए 4 पीक्स है, 3s के लिए 3 पीक्स are there, 2s के लिए 2 पीक्स एंड 1s के लिए 1 पीक. एंड द नंबर ऑफ नोड्स इज, we can calculate from this formula. For s orbital the L value is 0. So L का वैल्यू तो 0 लेंगे. ठीक है, क्योंकि s orbital है. So n minus 1. So if n is like 3, so total number of radial nodes will be 3 minus 1, 2. If n is 4, so total number of radial nodes will be 4 minus 1, 3. So these are the radial probability distribution function curves with respect to r. So this gives you the total probability. Total probability with respect to volume. Just draw them. Now let's see the curves for 2p, 3d and 4f. ठीक है, all the three have the similar curves. So this is the radial part of the wave function versus r, and probability density, radial probability density versus r, radial probability distribution function versus r. So almost all the curves are similar. So this is for 2p, 3d, 4f. ये क्या बता रहा है कि टोटल प्रोबेबिलिटी 0 नहीं हो रहा है. ठीक है, दैट मीन्स देयर इज नो रेडियल नोड. सो दिस देयर इज नो रेडियल नोड. We can calculate the radial nodes using the formula n minus 1. But as we can see, the n value is supposed to, ठीक है, L value is p orbital के लिए L value 1 है. So 2 minus 1 minus 1. So that will be for 2p, 2 minus 1 minus 1, that is nothing but 0. So if you calculate radial nodes for any of these three, it comes out to 0, right? So there are no nodes in 1s, 2p, 3d, 4f. The number of radial nodes are 0. Then if you look at the curve for 3p, 4d, 5f, 2p से 3p चला गया, 3d से 4d, 4f से 5f, है ना? तो one orbital we have shifted, one shell we have shifted. So here we have positive and negative part both. जो negative part है, जब उसको square करेंगे as in r square, so this becomes positive. ठीक है, तो जो ये curve है, just the negative part, when you square it up, it becomes positive. And then when you take the total probability, तो यहाँ पर क्या हो रहा है, हम probability density को r से multiply कर रहे हैं. तो जैसे जैसे r increase करेगा, total probability भी increase करेगा. ठीक है, तो the curves कैसे हो रहा है, पीक इंक्रीज कर रहा है ना, तो इंक्रीजिंग ऑर्डर में होगा, बिकॉज एज आर इंक्रीजेस द टोटल प्रोबेबिलिटी आल्सो इंक्रीजेस, बिकॉज वी आर मल्टीप्लाइंग प्रोबेबिलिटी डेंसिटी विद आर. सो दीज आर द कर्व्स फॉर 3p, 4d and 5f. Wave radial part of the wave function, radial probability density, radial probability distribution function with respect to distance from the nucleus. Likewise we have curves for 4p, 5d, 6f. तो हमने एक और शेल शिफ्ट किया, 3p से 4p, 4d to 5d, 5f to 6f. So here this is the radial part of the wave function. So यहाँ पर भी जो negative part of the function है, जब उसको squaring करेंगे तो ये positive हो जाएगा, right? And when we take the total probability, so we have again 3 peaks in increasing order, and the point where the electron density becomes 0, that represents node, right? So in this case, we have one node. In case of 3p, 4d and 5f, there will be one node. Whereas in case of 4p, 5d and 6f, there will be two radial nodes. So the regions where the total probability becomes 0 represents the nodal regions. So number of nodes can be calculated using the formula. Number of radial nodes is n minus 1. Okay, so these curves you have to just go through. So the equations are not important, although these curves have been, these are based on certain equations, but the equations are not important. So you just have to go through the curves. So just draw them, go through them quickly.